Tooling is where blockchain architecture becomes real. The SDKs, libraries, APIs, and operational tools you choose shape how teams build smart contracts, connect applications, access nodes, monitor risk, and run secure production systems. We've moved from architecture foundations into platform evaluation. Now the focus shifts to the implementation toolkit. SDKs, libraries, node services, testing, and monitoring. The goal is not simply to choose a blockchain. It is to be ready to build and operate on it. Tooling is not a side decision. In digital asset platforms, it affects how quickly teams ship, how safely contracts evolve, and whether compliance, monitoring, and incident response are built in from the start. Think of the enterprise blockchain toolchain as a lifecycle, not just a toolbox. Developers write contracts using frameworks and trusted libraries. Security tools test assumptions before production. Integration tools connect contracts to wallets, custody, and business applications. Underneath, access and data services provide reliable RPC, indexing, events, and explorers. Around the whole system are monitoring and incident response, because blockchain software keeps operating after deployment, and failures can be public, permanent, and expensive. For EVM-based token systems, the tooling works as a stack, not a menu of substitutes. Solidity is the contract language. OpenZeppelin provides audited building blocks for standards, roles, upgrades, and common security patterns. Hardhat and Foundry support professional engineering with tests, scripts, deployments, and automation. Remix is lighter weight and useful for learning or quick prototypes. For regulated assets, the architectural goal is consistency. Proven libraries, repeatable workflows, and testable deployment processes. Hardhat, Foundry, and Remix serve different moments in delivery. Hardhat fits JavaScript and TypeScript teams that need plugins and integration testing. Foundry is faster and more Solidity native, with strong fuzzing and rapid developer feedback. Remix is excellent for learning, demos, and quick experiments, but it should not be the backbone of enterprise CI/CD. Architecture standards should approve toolchains based on reproducible builds, testing depth, deployment controls, and security review. OpenZeppelin contracts helps teams avoid reinventing risky smart contract logic. It provides reviewed implementations for ERC20, ERC721, ERC1155, access control, pausing, reentrancy protection, time locks, and upgrade patterns. But libraries do not replace governance. Enterprise architects should approve specific versions, define when upgrades are allowed, document exceptions, and still require testing and audits. The aim is less custom code, with clear control over how shared components enter production. Smart contract security works best as a pipeline, not a final checklist. Slither gives fast static feedback on risky patterns and code quality. Mithril goes deeper with symbolic execution, exploring paths humans may miss. Echidna attacks assumptions through fuzzing, checking that key invariants always hold. Tenderly supports simulation, debugging, monitoring, and incident response once transactions become real. Together, these tools help reduce irreversible damage before, during, and after deployment. Integration libraries are the bridge between business software and blockchain networks. They let portals and backend services read state, send transactions, and call smart contracts without hand-building every protocol detail. For Ethereum-style chains, Ethers.js is mature and wallet-friendly Web3. JS remains common in legacy systems, and VM offers a modern TypeScript-first approach. Selection should consider documentation, ecosystem adoption, maintainability, type safety, and chain compatibility. Non-EVM networks usually require different SDKs. Transaction integration should follow a controlled path from intent to finality. Wallet Connect supports user-initiated approvals, where a wallet signs only what the user authorizes. For treasury or admin actions, Safe SDK adds multi-signature rules so no single operator can move assets alone. Fireblocks adds institutional custody, policy checks, and secure signing. OpenZeppelin Defender supports relayers, automation, monitoring, and contract operations. The goal is clear separation between request, approval, signature, submission, and confirmation. RPC access is the application's gateway to the chain, so reliability matters. Managed providers such as Infura, Alchemy, and QuickNode offer fast setup, elastic capacity, dashboards, and support. They can also introduce rate limits, vendor dependency, and data exposure. Self-hosted nodes improve control, privacy, and independence, but require more operational cost and expertise. Many production teams use a hybrid model with failover, latency monitoring, and clear SLA and compliance checks. Raw RPC data is useful, but it is rarely enough for enterprise products. Applications need data that can be searched, filtered, reconciled, and trusted. Block explorers provide human visibility into transactions, balances, and contracts. Event listeners react to contract events such as transfers, mints, burns, whitelist updates, or settlements. Indexers and subgraphs turn that activity into queryable APIs. The architecture also needs latency expectations, reorg handling, replay logic, and clear source of truth rules. A full node is usually enough for current balances, recent activity, and normal transaction processing. Some institutional workflows, however, need to reconstruct what the chain looked like at a specific past block. That is where archival data matters. Audits, investigations, tax reporting, and reconciliation may all depend on it. The trade-off is cost and complexity. Teams should decide whether an archival RPC provider, a self-hosted archival node, or an indexed database best fits the requirement. Tooling selection is an architecture decision, not a preference contest. For each SDK, API, node provider, or monitoring tool, evaluate functionality, security, ecosystem maturity, support, licensing, and cost. Then test compatibility with your token standard, custody model, compliance controls, and deployment strategy. The outcome should be explicit standards, approved libraries, CI/CD patterns, monitoring expectations, SLAs, and runbooks. Capture the rationale in an ADR, so future teams understand why the choice was made. The key takeaway is that platform selection is never just a chain choice. It depends on how you build securely, integrate reliably, and operate with confidence. The tools we covered become decision evidence. Next, we'll turn that evidence into a structured framework that balances business needs, regulation, security, and operations.